Welcome everyone to the Acceldata Accel Edge technical webinar series for the month of November. I'm Tej from the Acceldata Academy and your host for the session. Today we have Akshay, our very own resident solution architect, who will cover insights on Nifi configuration and share some of the best practices for optimizing Apache Nifi for performance, scalability, and reliability. Over to you, Akshay, for a quick intro and kick off the session.
Thanks, Tej. Hello, everyone. Thanks for joining in. My name is Akshay. I'm working as an RS in Acceldata. I've been into this Hadoop space for over a decade now. Let me, without wasting any further time, let me just dive deep into the best practices configuration. So I'll just quickly share my screen. Give me a second, guys. Let me know if you guys can see my screen.
Yes, Akshay, it's come up. Thank you.
Right, cool. All right. Give me 1 second. So Tej, you're able to see my screen, right? All
Yes,
right, cool.
I can. Yeah.
All right. All right. So welcome everyone again. Thanks for joining us today, spending your valuable time with us. In this session, we are going to explore one of the most important aspects of running Apache NiFi at scale, which is getting the configurations right. Whether you are building a new data pipelines or tuning your existing ones, the foundation of performance, reliability, and scalability starts with how NiFi is configured and deployed. Today we'll walk through the best practices, some real world recommendation, design principles you need to ensure in your NiFi environments to operate smoothly and efficiently. Right. So without first talking about server-side recommendations, it would not make sense, much more sense to talk about NiFi before that.
Akshay,
So
sorry to interrupt. There is one presenter view slide which is showing up
oh,
in
okay,
front. Yeah.
that's what I was thinking. So give me 1 second. Let me just. We need to start again then, I think.
No, that's okay. I think it should
Okay.
be okay. Yeah.
Let me see if I can only share.
The first part is okay because it's just talking about what the session is about. Yeah.
Okay. Is it okay now?
System server recommendations.
All right. Cool. So we'll start
Great.
from here then.
Yeah.
Okay. Okay. Let's discuss some of the system server related recommendations before discussing about NiFi service related configurations and tuning. So we know that the NiFi service is designed to take full advantage of the hardware resources of the server it is installed on. So it is for this reason we strongly recommend against co-locating any other service with NiFi in order to achieve best performance. NiFi as a service, we know that it works with variety of files and large number of files. So it is important for us to make sure that the maximum file handles are configured correctly, because NiFi will create new flow files. It will roll the logs. It will do the compaction of the journals, clean up the content flow file repositories. So make sure your maximum file handle u limits have been set properly for NiFi as the user. NiFi may be configured to generate a significant number of threads, which also depends upon your application use case. So make sure the nproc or the maximum fork process for the NiFi user u limit is set correctly. Now, talking about the TCP socket ports. So, so, so talking about the TCP socket ports, this is particularly important if your flow will be setting up or tearing down a large number of sockets in a small period of time. So make sure the kernel parameter with respect to the IP local port range for IPv4 is tuned properly. Now we have, in my experience working in NiFi, we have seen issues with timed wait connections. So you don't want your sockets to sit and linger too long, given that you won't be able to you won't be able to quickly set up and tear down new sockets. It's a good idea to read more about it, but you can adjust the kernel parameter, that is contract TCP timeout time wait to 1. So we all know that okay, Linux system uses swappiness feature. This swappiness functionality is, I think it depends on application to application. For few services, the swappiness might give you a better performance. While for services like Nifi, you know, that always wants to be running, it is ideally recommended to disable the swappiness. The another system level configuration which I want to talk about is the access time. So for if your now NiFi directories are mounted on ext3 or ext4 file systems, make sure to turn off the A time in your FS tab. For disks using XFS file system, the default behavior is real time, which has almost no overhead compared to no A time configured, but still maintains a good A time values. So there is no reason for XFS file system to ever use no A time for performance reasons. Last but not the least, your NTP time synchronization. Make sure that the time is in sync, your NTP server is in sync with each other. Now, let's dive into the NiFi related best practices. Now, achieving the best possible performance in NiFi starts here, right? The flow file, content, provenance repositories must be isolated to their own separate physical disk. In process of moving the flow files through your design data flows, information will be written continuously to each of these repositories, representing considerable amount of disk IO usage with transaction overhead. The recommendation is to have these repositories use a RAID to improve performance and add a layer of data protection like RAID 1 and or RAID 10, which provides best performance. But both the content and provenance repository will support multiple repositories, right? Even better performance can be had having multiple repos each for each repositories on their own disk. While we are on the topic of physical separations of NiFi various repositories, the NiFi log directory should also reside on its own physical disk. It is often very, easy to kind of forget this, that we have seen customer cases where, the NiFi log directories had an impact on their overall NiFi performance. So as NiFi logging is very robust, it can contribute to a significant amount of IO itself. Let's talk about this configurations. I don't know. Sometimes we have seen that there are like small bits of pieces of configurations which often are overlooked. But I want to make sure we cover this in this webinar today. So NiFi board yield duration is one of those configs. So this property was designed to help with CPU utilization by preventing the processors that are using the timer driven scheduling strategy from using excessive CPU when there is actually no work to do, right? The default 10 milliseconds value already makes a huge impact on cutting down our CPU utilization. So smaller values equate to lower latency but higher CPU utilization. So depending on how important the latency is to you, your overall data flow, increasing the value here will cut down the overall CPU utilization even further. There is another property in this section that can be changed, and it does not have an impact on NiFi performance per se, but can have an impact on your browser experience, which is the auto refresh interval. So if this property sets the value at which the latest statistics, bulletins, and flow revisions will be refreshed, pushed to the connected browser session. In order to reload complete data flow, the user must trigger a refresh. Decreasing the time between refreshes will allow bulletins to present themselves to the user in timely manner. However, doing so will also increase the network bandwidth that is being used. Now, the number of concurrent users accessing the UI compounds this. In a multi-tenant setup of Nifi with lots of concurrent users, it is recommended that the auto refresh rate is kind of bumped up from 30 seconds to 60 or 120 seconds, depending how your cluster UI behaves. If the user wants the latest and greatest metrics or details, they can always do a right click refresh to get the status, right? Now, the Nifi H2 database. So basically, it's a database used by a Nifi, which has a user DB, which keeps a track of all the user logins, and it also has a history DB where it will create the audits of all the changes made on the graph. So again, if this by default this database repository is configured within the installation directory itself, so ideally it should be on a separate disk to give you the performance uh, impact or increase in your performance. So there was an interesting case that we had recently with one of our customer where their use case was uh, constantly submitting flows, destroying flows, starting, deleting, and that too on a multi-tenant setup. So initially, for a month or two, everything was working fine. And suddenly, from third month onwards, they started seeing their cluster getting disconnected, connected state on all the clusters. So obviously, there was some kind of a pattern because of which this was happening, and we have spent quite significant amount of time in the investigation doing root cause analysis, and later on realized that the bottleneck was H2 database. So because of the difference in the behavior of H2 versus Exodus, we provided them version which supports Exodus, and after migrating the Nifi version to Exodus, kind of solve that issue. So if you have similar kind of a use case, I would suggest using Exodus over H2 database. Um, Nifi timeouts. I think when you install in Nifi for the first time, the default timeouts are good for your starting for start. But eventually, as new flows are deployed into your Nifi UI, right, these timeouts will create issues. So one recommendation would be to tune timeouts before, as soon as you do the installation. Setting it to somewhere around 60 120 seconds is a good starting point and will have a stable behavior for a quite long period of time. And later on, if you see further issues with that, you can increase further, tune those timeouts as well. So flow file repository is by far the most important repository in Nifi, because we know that it maintains the state of all the flow files that are currently located anywhere in the data flows in your Nifi UI. So if this repository becomes corrupt, the potential exists that you could lose the access to some or all the flow files that are currently being worked upon Nifi. So the most common cause of corruption we have seen is disk running out of space. So you'll also want to have the flow file repository located on a separate disk, as we discussed earlier, which will definitely boost your performance. So NiFi does not move the physical file from processor to processor, right? Because the flow file serves as a unit of transfer from one processor to the next. Because the content lies in the content repository, while the flow file is the flow files, which are the attributes, are there in your flow file repositories. So the flow file, because the flow file serves as a unit of transfer in NiFi, in order to make sure the transfer is fast, what NiFi does is it keeps the flow file inside the JVM memory. Well, this sounds great, right? Until you have so many flow files that your system began to run out of heap memory or have serious performance implications or issues, right? So to reduce the likelihood of this happening, NiFi has a threshold that defines how many flow files can live in a memory in a single connection queue before it is being swapped to the disk, right? So the connections in Nifi are represented by arrows, right? And basically it is connecting two processes. Now the flow files can queue up on these connections while waiting for the subsequent processor to kind of process it, right? So the configurations that defines how many flow files can live in your Nifi JVM memory is your Nifi queue swap threshold. This is one of the very important key to performance, and if you minimize the number of swap files being swapped in and out of the connection, right? If the total number of flow files in any one of the connection kind of exceeds this limit, the swapping will occur. And the idea should be to avoid the swapping as much as we can, because it would be a costly operation, as it involves disk IO, and will have an impact on your latency as well. So let's say if this threshold is set to 20,000 or 10,000 or 8,000, whatever, right? As soon as the queue has that number of flow file, right, it will try to swap. But if you feel that 8,000, 10,000 flow files sitting in connection is a norm rather than an occasional data surge of your data flow, it may be wise to increase this value. So in order to do that, you'll need to closely monitor your heap usage and increase it as well to handle this larger queues. Since the swapping occurs per connection, setting this value higher in NiFi instance where you have very large data flow with lots of connection can lead to a very high heap usage. So you should make sure to use a connection back pressure object threshold to control how large each connection can get. The heap size, we know that we can set the heap size in Bootstrap. So there are certain things that you need to keep in mind. Setting the NiFi swap threshold too high can lead to high heap usage across your flow, while setting the connection back pressure object threshold larger than this queue threshold can lead to swapping. So avoid setting this too high except where absolutely needed in your data flow design. Moving on from NiFi flow to content repository, since the content of every flow file that is consumed by NiFi is placed inside this repository, uh, again, the first point would be to make sure it has a separate disk, because there will be high IOs on this particular directory, right? So NiFi allows you to configure multiple content repository within a single NiFi instance. NiFi will then use kind of round robin files to however many content repositories that are defined. This division of IO load across multiple disks can result in significant performance gains and durability in the event of the failures. The third repository is the provenance one. Similar to your content provenance, having a dedicated disk is a good indicator and helps with your performance. The default when you install NiFi, the default implementation is the persistent provenance repository. However, it is recommended to use write ahead provenance repositories, which yield far better performance results over any other available implementation. Now, we have we have been getting questions like, oh, can I use encrypted write ahead provenance instead of write ahead provenance? Well, the key here to understand is that the encryption of all provenance events adds a considerable transaction overhead, which will have an impact of NiFi performance. So keeping this thing in mind, one needs to take a decision whether one needs to use the write ahead or they should use encrypted write ahead provenance repository, right? Now, the ability to query performance information on the files has a great value to a variety of users, right? There will be use cases where you want to query your performance provenance data to kind of get the history or get the status, right? So the number of threads that are available to conduct the provenance queries on behalf of the user is defined by the provenance repository query threads. On the system where you have good amount of users having similar use case who wants to query the performance, it would be necessary to tune this thread further, right? The number of threads to use for indexing provenance events, so that kind of they are searchable and can be adjusted by this line. So as the provenance records are written, they are also indexed, right, which we just discussed. So you can also tune these indexing threads so that it becomes faster for NiFi to query the performance. Default value is set to 1. Consider increasing it further as well, because if you have use case around querying provenance, then these two configurations, that is the query threads and index threads, can be tuned further. Last but not the least, with respect to provenance, is your shard size. the larger value of the shard size will result in more Java heap usage when searching the provenance repository, but should provide you a better performance. The default value is 500 MB. This does not mean that 500 MB of heap is going to be used, but you have to keep in mind that if you increase the size of shard, you may also need to increase the size of the overall heap which is configured for your NiFi. Because the NiFi provenance uses Lucene indexes for basically querying provenance events, searching flow file attributes, time ranges searches, lineage tracing. Lucene performs better with smaller and frequently rotated shards. But too many shards, can increase your file count, open file handle, your query overhead. So shard size is a performance tuning knob affecting your disk, CPU, and search performance. So while tuning this, make sure you're observing your heap usage, your provenance query time, and based on that, you should take those decisions which knob to tune. So the another repository is your component status repository, right? So the NiFi component, whatever you add to the canvas, retains various different statistics, right? Those all those statistics basically live in heap memory, and this configuration dictate how many stats to hold in heap for each of those statistics. So the default value is set to, I think, somewhere around 1440 data points, where each data point is being captured every minute. This configuration gives you 24 hours of stats history for every statistics. Now, while these data points each represent a very tiny bit of information, but consider a NiFi cluster with a huge amount of processes, large data flows for different tenants, right? This immediately will contribute to a significant chunk of heap usage. Now, if this starts, the user may start to notice, performance issues with NiFi. So the configuration, which is your buffer size, right? You can change this value to something smaller instead of 1140, for example, 200, 300 data points, right? And then you can also reduce the frequency in which the snapshot is being taken. So changing the frequency of the data points that are being collected will allow you to retain more history over a time, even with fewer data points. So this is basically, so basically a buffer size with somewhere around 288 or 300 data points and snapshot frequency of 5 minutes will still hold 24-hour statistics for every component with less amount of heap usage. So moving on to the next configuration, which is your timer driven thread count. I've always seen confusions with users whether this property is at a cluster level, node level, questions around this, right? So let's understand first what exactly is this. You have a NiFi processor which you can configure uh, for using timer driven strategy and event based strategy, although the event based strategy is going to get deprecated, but I've seen most of the use cases around timer driven strategy, right? So the general guidance for setting this value is basically 2 to 4 times the number of cores that are available on the hardware on which your NiFi service is running. Now, with a NiFi cluster where each server has a different hardware, this would be set to the highest value possible based on the server with the least cores. So let's say if you have three servers with, let's say, 8, 10, 12 cores, you would want to set this value based on the lowest number of cores, which is 8, and you can multiply by 2 or maximum 4 times of 8 cores and set the value of this property. Now, closely monitoring your CPU usage over a time on each of your cluster node will help you to identify irregular or routine spikes in the usage, right? This information will help you to identify if you can further increase your timer driven thread count, or I mean, if you increase it, will you get any performance benefits? Because if your CPU utilization is already spiked and you just keep on increasing this value, there will be no performance benefit from that, right? So Yeah, I mean, this is one of the most important configurations, I would say, for making sure the right amount of threads are available for the process. So concurrent task, right? So we discussed about the timer driven threads, and now I've again there is a behavior with users of Nifi where each tenant is trying to develop their own flow, and while doing the testing they see that, oh, my flow is not processing faster, so let me just bump up the concurrent task so that it will process the flow file at a better rate as compared to setting it to the lower value, right? But while doing so, what happens is, overall, when similar, like when there are multiple tenants doing this, following the same practice, at some point in time your Nifi will have flows, and most of the processor will have multiple concurrent tasks, right? So the process that are using one concurrent task will have an impact because of the process configured using multiple concurrent tasks, right? So a decision needs to be made by the application team, and I think a platform team needs to kind of assist to the application team to understand what's the best concurrent task value for a given particular processor. Because what happens is the user's process running only with one concurrent task will never get the thread, because the other process which has higher concurrent task have request in the queue, and threads are just processing those tasks. So this is one of the common patterns that I have seen. So make sure you have the platform team and the application team kind of work to collaborate in a collaborative fashion to decide what is the right value of the concurrent task. Controlling the heap space, I think one of the major factor that has pressure on heap is the flow file attributes, because as we discussed, the flow files are maintained in your Nifi JVM so that they are transferred faster. So some some strategies is basically to avoid creating unnecessary attributes, right, of the flow files. uh, when so if you don't need an attribute, don't create it, right? It will simply reduce the number of objects in your heap. And then I've seen use cases where the customers have kind of created added one attribute, but they were trying to store data in the value in the attribute. So if you need like a higher large amount of data stored as an attribute, I would rather suggest storing it as a content instead of an attribute, to avoid heap pressure on your Nifi JVM, right? Excellent. So now we have got our Nifi foundation solid, right? We have tuned our Nifi JVM. We have optimized our repository configuration settings. uh, we have essentially basically tuned our engine, right? But just a powerful engine alone doesn't guarantee winning a race car, right? You need an efficient chassis and a smart design, right? So this brings us to the new critical layer, which is our data flow design principles and recommendations. This is where we, as developer architects, have the most direct control over performance and efficiency. The choice we make on canvas, how we structure our flows, how we handle data, will ultimately determine whether a well-tuned engine purrs or struggles. So we are now moving from system level configurations to application level best practices. So let's start with one of the highest impact, yet most common areas we need to get right. So there are certain flow design principles which I have laid out, I think are crucial to get the best out of Nifi. So first is your keeping your flows modular, right? What I mean by that is, while when a user goes through a journey of creating a data flow where he or she wants to kind of process read the data from one source and do some kind of modification transformations and send it to a destination, uh, one becomes so engaged in achieving that use cases, they just kind of create one single flow, and eventually results into creating a very huge or large data flows. So it is important to take a step back and think that how can I design this flow in such a way, or how can I divide this flow into smaller chunks where I can make the same flow reusable, or some reusable, basically subflows, right? So it is very important whenever one is trying to design a data flow, to keep this point in mind. Make sure your flows can be reusable, otherwise you just end up adding more and more components in Nifi UI. um, the process group is one of the, again, is a kind of concept in Nifi which helps you to bifurcate, divide, and conquer your use case, right? Having process groups gives you a good segregation, and it becomes easy when there are huge number of flow files to understand in which process group which flows exist, right? So example, you have, let's say, ingestion, transformation, delivery. You can basically divide all this task into subtask using process groups, and later on when you go to Nifi UI, it becomes easy for managing, understanding your canvas as well. um, there are often cases where we want to configure database connection strings, passwords, trust stores, key stores, Kerberos credentials, right? Instead of hard coding a particular configuration, use parameter context. Using will context will help you to reuse those configurations in multiple flows. And last but not the least, avoiding hard dependencies. So basically, as we discussed earlier, one a particular user, when they want to create a data flow, they are so much into that thought process that they end up creating a huge and large data flow that is dependent on each other, right? So the idea here is to design a data flow in such a way that a failure in one area should not have an impact on the second or the other part of the areas of your data flow, right? So for an example, let's say you have a get file processor which is writing to a put database, which is writing to a database using a put database record. Let's say you're doing some modifications and bit transformations in between this, but just to keep it simple, there is a get file and there is a put database, and there can be multiple processor within these two processors. So if you design this data flow in this way, right? Now think about what will happen if the database goes down, right? The flow files will be lying around in the queue of the parent processor of put database processor, and will have a snowball impact, right? Eventually, because the Nifi back pressure will hit, and then this will again block your get file process, where no new files would be ingested. So one failure over here, which is your database outage, cascades and halts the whole pipeline. So instead of this, a good design would be have a get file processor, followed by your publish Kafka processor, which is writing to a Kafka topic, which is your ingestion, basically ingestion flow. And then you have a subsequent consume Kafka processor, which is consuming from the same topic, and then write to your database. In this case, what will happen is, if your database is down, right, the flow files are still published to Kafka. Your Nifi ingestion continues without interruption. And once the database comes back online, your consume Kafka can start resuming the flow files, and then the put database can start processing it and writing it to the database. So this is one of the example where you can isolate your ingestion so ingestion into Nifi and processing database flow. So I think we already discussed about tuning concurrent task, but make sure the concurrent task matches to your available CPU cores and the processor workload. So monitoring your CPU utilization while tuning the concurrent task is mandatory and should be used. There's no point in increasing your concurrent task if your Nifi CPU is already spiked up, right? Use back pressure, set the thresholds on the connection level to prevent the memory exhaustion. um, Another point would be to leverage remote process group. So for an example, let's assume a use case. You have a central Wi-Fi cluster which is handling data ingestion from, let's say, 100 IoT devices. Now, instead of directly writing the data to HDFS from the central flow, which can overwhelm your one cluster, what you can do is use a Nifi remote process group that pushes the subsets of data to the regional Nifi cluster. Now, each regional cluster does local enrichment, transformation, and delivery. So the result would be like your workload is distributed. You have a central Nifi that doesn't become a bottleneck, and you gain a fault isolation. So one cluster failing doesn't have an impact on the other. uh, Batch where is possible, I cannot stress on this enough. uh, Batching, uh, batching in having a batch level insert writes instead of single record operations will give you better performance and latency as compared to ingesting one single record. So for an example, you have a consume kappa put database record, right? um, if you write one record at a time, the database gets hammered with thousands of tiny writes. And then we have seen an issue with Oracle where there was a restriction on how many requests or how many writes a particular user can make, which resulted into this issue. So we had to tune the flow to kind of batch the records and then write it to the database. So what this helps you to do is avoid hitting any restrictions or limits that are configured on your database side. It reduces the DB load and the transaction overhead, and you'll get a higher throughput as well with lower latency. Error handling and resilience. So we all know when we create our flow files or when we create our NiFi flows, we often see failures, right? And handling those failures is one of the important aspects of understanding where your flow is failing. How can you improve your flow to handle those kind of failures, identify race conditions, right? So for an example, let's say, again, I'll take a very simple example over here, a get file and a put database record, right? You can have the success relation of your put database record to some kind of a downstream processor which will confirm your okay inserts have been confirmed, right? And then you can have your retry you can have your retry relation of your put database record. If basically is temporary, if your database temporary unavailable, you can route to a retry queue with wait and notify, or just do a retry flow files. Now, even after the retry, there would be some flow files which would eventually fail, right? So these unrecoverable errors can go to this particular failure relationships, and this ensures that your bad data doesn't block your good data, and temporary failure don't causes flow wide cascades. Now, one of this failure can be also routed to your dead letter queues, right? Basically, sending your unrecoverable failures to this DL queue for later inspection, which will help you to understand if there is any inconsistency in the data that you are processing, any race conditions that you might have not um, thought for, right? So this would help you to reduce the amount of failures that would be happening while your flows are getting processed. Now, using appropriate retry count and backoff to avoid the infinite loop. So you don't want, if we discussed about having a retry relationship, right? But then you don't want to end up doing a retry forever. At some point in time, it needs to kind of back off and say that, oh, I have done my retries with maximum effort, and then let me just now send the flow file to the DLQ for later inspection. For data So data provenance tracking, I know we discussed about data provenance, right? But you may have an impact on data provenance performance if you're tracking the content of the flow file as well, right? Not every use case is required for you to track the content in provenance. So make sure that you are tracking the flow files in the provenance with data only when it is required. This will help the cluster performance as well as your flow files or your flows to get a better performance. um, Maintainability and governance. So we develop so many flows, right? Sometimes it becomes difficult to understand and manage so many versions of flow. This is where NiFi registry is very useful. Basically, it acts as a git for your NiFi flows. It allows you to do the version control, every whenever you make a change in your flow. And this also means that you can see exactly who changed what and when, which helps you to understand maybe the reasoning behind the change, the justification. Instead of, if you don't have a NiFi registry, it is very difficult and hard to maintain, right? Naming standards is important, I would say, for, first of all, obviously, for understanding what exactly is that particular process flow used for. Secondly, it plays a very important role when you want to monitor, and that point will cover at the end of the slide. But the two main thing is, have a clear naming process helps you in a long run. A canvas full of process named with generate flow file 1 2 3 or replace text 4 5 6 is really unmaintainable. And you must name the components based on your business function, not their processor type. Documentation, again, along with your naming conventions. I think if you document, create labels uh, around the process group, around the flows, it helps and makes it easy for humans to read. So for a processor, that might be expected an input format or a link to an API specification. For a process group, if it's a high level summary of a business logic, it performs. For a variable, if it's explaining what it controls, what a valid value would look like, right? This isn't about creating an external documentation that becomes outdated. It's about embedding the why directly into the canvas, right? uh, it Because at some point in time your canvas is going to get very huge, right? So having good amount of documentations makes it easy to understand why uh, for that particular process group flow, whatever it may be. Now, monitoring and alerting. um, I would like you guys to kind of encourage you guys to go and visit the Acceldata Pulse documentation for NiFi. The Acceldata Pulse for basically doing a proactive level of monitoring. Finally, I think we are moving from reactive firefighting to a proactive monitoring and alerting. Now, if in our previous slides we talked about component status history, right? Now, that gives you the data every 5 minutes, but imagine you want to have an historical data of how a particular flow, how a particular process have been performing. That is not available because the history retained by NiFi is for 24 hours only. So having an historic information about your NiFi helps you to identify trends, bottlenecks, data surges, which helps you to take decision. Otherwise, it becomes difficult to take decisions, and you, even though if you take decisions, it would be on assumptions rather than the data points. So we have Accelerate Pulse for NiFi, which gives you kind of a great baseline metrics. It's a unified enterprise grade view of our data flows. It allows you to see the real time health performance across our entire NiFi landscape. More importantly, you can configure smart alert based on key condition. For example, let's say there is a sudden drop in the throughput of my flow. I want to get an alert. So instead of doing a reactive troubleshooting, you can do a proactive troubleshooting, because now you got an alert and saying that, oh, there's a drop in throughput. You go and try to identify where the bottleneck is. So in summary, I think together these four practices: version control, naming standard, embedded documentation, and having a proactive monitoring alerting setup with historic data, you know, gives you it forms the backbone of a sustainable, supportable, and resilient data flow management practice. So these are what proof of concept from a production grade asset, right? Uh, I think I have. Oh, okay. There's one last thing that I wanted to cover. I think this is one of the very minor thing, but sometimes I think we might miss it. So one, I just wanted to quickly highlight over here that in your Nifi documentation, whenever developers are creating flows, right? Always try to see the process resource consideration for that particular processor. That gives you a understanding whether the particular processor, if I'm going to use it, would be a CPU intensive, memory intensive. Based on that, this simple check basically is your first line of defense against any unexpected resource exhaustion, and you also get an understanding of what this process is going to do. I think that's all from my side. Again, thank you for joining and giving your time. Have a good day. Bye, guys.